Hi folks, let's play another puzzle from the Bratzka section, which is the easiest version of full deck and missing a few cards. This one is called Starting Points. And we have standard 1 to 9 rules, so every row, column, and 3x3 marked region by heavy black dashed lines must contain the digits 1 to 9 once each. And then we've got some arrows, things on the shaft of an arrow. So these have to sum to the digit in the circle, which is that one. So, and we'll start with the 6 arrow. 6 and 3 cells minimized has to be 1, 2, 3. And in fact, if I maximize anything else, I end up with something higher than 6. This 3 can only be formed by 1, 2, and this 1 tells me which way around that goes. 5 and 2 cells, well, that's 4, 1, or 2, 3. And you guessed it, that can't be 1, 2, or 3, so that's a 4, which goes with 1. So this one, now, it could actually still be 1, 4 this way around. Or it could be 2, 3 either way around. 6 minimized with 1, 2 makes that cell a 9. Let's see, this has to be 6, right? Plus, that can't be 1 because this can't be 7. So this is either 2 or 3 to make either 8 or 9. Now 6, 1, 2, well guess what, that's 3. And 3 plus 2 is 5. So 5 can't go here. By Sudoku, 5 is there. We're here in column 8. That puts 5 down here and potentially on the line. However, this goes 3 cells. That has to be 1, 2, 3 at least. But there's a 3 here, so this is a minimum of 1, 2, 4. That can't be 5, and this could be 7 or 9, but it sees a 7 and a 9, so that has to be an 8. Now, how do I make 8 in 3 cells with a 5 on it? This is 3, 5. That's the only way that works. Now, these cells can't be 3 or 5. So I think I'm looking at 1, 2, 6 because no. 1, 2, 4, 7. 1, 2, 5 is 8. Right? This is 1, 2, 5 or 1, 3, 4. Well, none of these can be a 3. So I think this has to be 1, 2, 5. And the 5 goes here. And this is 1, 2. I don't know how I put that down as an R. And the 2 in column 7 tells me which way that 1, 2 goes. This is 4, 6, 9, but that can't be 6. Okay, now this one can't be 1, 2, 3, 5, or 8. Now, can this be 9? Well, those all see a 5. 3, 6, well, this can't be a 6, this can't be a 3. Three, 6, this could still be 9. But actually, this could be, theoretically, 1, 3 to make 4. That could even be a 2, 1 to make 3. Well, it can't. Let's see, this is 4 and 7. I know which way around they go in column 9. So that can't be a 1. So 1 is there. Well, this is 1, 3, 8. It can't be 9 because 9 can never be on an arrow. And if this was 8, that would have to be at least a 1, which clashes with this one, or anything bigger makes that cell too big because it's 2 digits. So this is not 8. Now, this can't be 3, and it can't be 1, and it can't be 8. But 1, 2, 3, 5, 8. This is 4, 6, 7, or 9, right? And we know these cells are not 4. 9 can never appear on an arrow. Well, 3 plus 6 is 9 works. 1 plus 7 is 8 does not work. 1 plus 6 is 7 does work. What we do know is that this cell is not 6. 3, 6 is 9, 1 and 6 is 7. Those are the only two possibilities from those digits. Either way, we know this cell cannot be 7 because 7 and 1 does not make 8, and 3 and 8 is too big. So, I believe we've established that that's a 6. Okay, that does put 4 here. Don't know much beyond that, though. I wish I did. 4, 5, 6, 7. Okay, I need 1, 3, 8, and 9. Well, we've established the 8 must appear either here or... Actually, this could still be 8, which is annoying. I don't know anything more about this arrow. Okay, what about this 7? Minimize, that's 1, 2, 4. If the 1 was moved up, 2, 1, 4 is just a repeat. And I get 2, 3, and it's either 2, which doesn't work by Sudoku or cage rules, or 2, 3, 3, and then 2, 3, 4 is too big, so this is 1, 2, 4. Actually, and this cell in row 8, column 1 sees a 1 and a 2, and that's going to sort out the rest of the arrow, which means this is 9, that's 6, that's 4. This is now 8, so 6 plus 2 is 8. That's a 4, and this isn't. That now can't be 1. This is 3 plus 6 to make 9, which sorts out this arrow. This not being 2 doesn't help. I still have this, which is annoying. Let's see, I've got 3, 5 there. Unfortunately, that doesn't help me with much of anything. I do get a 3, 5 pair in row 7 and row 8. So this is now 6 and 8. And this... 2, 3, 4, 5, 6, 8. Okay, this is 7, 9. And that's also not settled. Okay, 3, 5, 8, 9 go here. In column 1. But that doesn't tell us anything that we don't already know. Two, 3, 8, 9. Remember, 9 can never go on an arrow, and this isn't 2 because it sees a 2 in its box. This sees 2, 3, 9. That must be 8. Now, this can't be 2 or 9, so that is a 3, which means this is 9. And that's a 2, and then... that sorts out the 5, 3, and the 3, 5 on the arrow. Perhaps more importantly, that sorts out this arrow. This is 5, 8, so that's a 3. Now, will I need Sudoku, or can I do this one? Okay. 1, 2, 3, 5, 6. So let's see what this could be. 4, 7, 8, 9. Well, if it's 4, it's double 2, or it's 1, 3, so that doesn't work. Okay, 7. It sees 1, 6. It sees 2, 5, and 3. this could actually still be 4. So yes, it can be 7. 8 would be either double 4, which doesn't work for multiple reasons, 3, 5, both of which are seen, 2, 6, both of which are seen, and 1, 7, but this given 1 rules that out, so this cannot be an 8. What about 9? Well, 8, 1 is ruled the same way. The 8 was ruled out by 7, 1 earlier. 7, 2, it's both seen. 3, 6, and 4, 5 are the same way, so this, in fact, must be 7. That is a 4. That's the only way this arrow works. 1, 2, 3, 6, 8, 9. This ends up as 4, 5, and 7. Which goes that way around. And I think now we've done all the arrows. I believe we now have classic Sudoku at this point. This 7 going this way around can't be 3, 4. Could it be 2, 5? No, because both of these cells see a 2, so it's 1, 6. And the 1 in column 5 points up to tell me that the arrow digit is a 6 with a 1 next to it. Okay, that solves all my arrow clues, yay. And at this point, we are down to classic. 6, 4, no, 8. These are 5 and 7. I know the order. This row is missing its 9. Let's see. This is missing 4 and 5 in row 1. That's missing a 9. That's missing an 8. Okay, this is 2, 7, 8. This isn't 7. Oh, there we go. 2, 4, 5, 6, 7. This is 3, 8, 9. Just a 9 here, flanked by a 3 and 8. And there's a 3 in column 4 that points down. Yay. And that will finally resolve my last pairs. Well, this was a rather very haphazard way of solving it. I'm missing 5, 6, and 7, and they go this way. Cool. Well, that's the end of the Bracegift series, at least all the ones that I've done, until they post another one, but I finally figured out you had to solve the arrows in a specific order. This one took me a couple of tries. And this arrow in box 1 at the very bottom right was a particular thorn. I kept running into conflicts that usually ended up with too many possibilities going south and east from the stem of that arrow.